Hello students, this is the second lesson in the 10th unit. This is also on circle equations, but we're going to get a little more algebraic. We're going to be talking about what happens when they give you the endpoints of a diameter, and we're going to be talking about how to take that information about the radius and the diameter to answer other questions about circles, not just their equations or their graphs, but maybe their other aspects like area and circumference. All right. The learning target for today is extending our knowledge of the connections between algebraic equation of the circle and its characteristics. And we're going to take characteristics beyond as well because as of last lesson, we talked about the characteristics of a circle being the center and the radius. However, in this case, we're going to be talking about other characteristics, like I said, like area and circumference as well as diameter. In the do now, it says circle A, and we name a circle based on its center. So the center is at 0, 0. So we know that this point here, 0, 0, is now point A. Point P, which is 3, 4, is on the circle's edge. So let's graph the circle and set of the axes at right. I'm not going to make you wait for this. I'll just do it and you do it on your own paper. Okay, we have the circle A with its center here, and point P is over here. Let's label those points actually. And when we draw a circle generally, we try to draw that circle so that all of the points all the way around are labeled. However, in this case, we don't really know exactly how long this radius is. In other problems, we knew that, for example, if this was the center 0, 0, we just count boxes in order to get to the next part. We'd count boxes to figure out the radius. However, we can't really count the boxes here because it's along a diagonal. So, in order to draw the rest of the circle, we sort of have to figure it out. I know that in order to get from the center to the edge here is 3, 4. Well, if I go another 3, 4 out here, this should also be on the edge of the circle. And then similarly, 3, 4 the other direction, like down, and down in the other way, should be on the edge of the circle as well. And similarly, anything that's 4, 3 should be on the edge of the circle as well. 4, 3, 4, 3, and 4, 3. So now we're starting to see the circle a little bit better. And we just figured that out by saying, well, if I take this radius and I swing it all the way around, that should give me a pretty good idea of what the circle should look like. And if I draw the entire circle by connecting all of these dots and rounding it out, it sort of looks pretty much like this radius is going to be around 5. Pretty close to 5, actually, like really close to 5. Anyway, that's graphing the circle on the set of axes. Moving on, let's think about it. What do we need to write the equation of a circle? What information is missing? And what can we do to determine that missing information? Pause that video and try this out and then come back to see if you got it right. All right, for this first part, it asks, what do we need to write the equation of a circle? And you know that we use the center and the radius to do so. The center is h, k, the radius is r. This is just a brief review of what we learned yesterday. What information is missing from the do now? Well, we're given the center. We just don't know the radius, right? So the missing information from the do now is the radius. So now we're in a bit of a bind. What can we do to determine that missing information? Well, all we know is the endpoint of the radius and the other endpoint of the radius. So we have two endpoints of a straight line segment. How do we find the distance between those two endpoints on a graph? Oh, we have the distance formula. So it wouldn't be that hard to find the measure of the radius, which in this case we're abbreviating as d, the distance between these 2 points. Keep in mind we're finding the radius. All right. From the circle equation from the do now, we know that the center is at 0, 0 and the point is at 3, 4. How do we write the equation of the circle? Well, first, let's find the radius. And as we said before, we're going to take the distance formula and use that to find the radius. In the distance formula, we use x2 minus x1 and y2 minus y1. Let's label up the points here and then substitute them into that formula. All right, now that we have the labels, we can substitute them into the formula here. Keeping in mind that this d represents the distance between these 2 points, we're going to switch that to r because we're really finding the radius. So here we've substituted the values into the equation. Now let's simplify. We get 9 plus 16, 3 squared plus 4 squared, then square root of 25 is equal to 5. So we know that the radius of this circle is 5. We can combine that with the center to actually write the equation of the circle. And as you recall, h, k, and r are the things that we have to substitute into the circle equation. H and k are the y and x of the center, and then r is the radius of that same circle. So we know that h and k are 0 and 0 respectively, and we know that r, now we know that r is 5. We can substitute that into the circle equation like this. And in this particular case, since it's x minus 0 and y minus 0, we can simplify those to just x and y, and 5 squared is just 25. Speaking of the radius of the circle, going back a little bit, that radius was equal to 5. And as you remember, in the do now, that radius looked suspiciously close to 5 anyway. So it sort of turns out that we were able to verify the fact that the radius is 5, which we suspected from the do now when we graphed it. All right, moving on to the check for understanding. This is something that you're going to be doing in class. So let's actually take a quick look at the anatomy of a circle. You already know some of these facts. One of the facts that we're going to talk about is that a circle's center is equidistant from all points on its edge. That word equidistant means equal distances. And it also says all radii, which is the plural of radius, of a circle are congruent. So this radius is the same as this radius. If I were to draw another radius, it would be the same distance as well. So for example, this radius is the same length as this radius or this radius. A straight line segment drawn from any point on the edge of a circle to the center is called the radius. So I'm going from the edge to the center, edge to the center, edge to the center. Those are all called radii. A straight line segment drawn from any point on the edge of a circle to another point on the edge that passes through the center is called the diameter. That is the longest distance through a circle, incidentally, the diameter. And now the diameter doesn't have to be drawn horizontally. It could be drawn vertically or diagonally, whichever way, as long as it touches 2 points on the edge and passes through the center. That's it. That's called the diameter. Diameter of a circle is twice the length of the radius because a diameter is essentially 2 radiuses put together. And the center of a circle is the midpoint of all diameters of the circle. So in other words, this point, the center, is directly in between this point and this point. It's the midpoint. That's going to be important later. Remember that the center of the circle is the midpoint of all diameters of the circle. Take a look at the model problem. It tells us that the endpoints of the diameter of a circle, C, are at -6, -4, and -2, 2. It asks us to first graph the circle, then find its characteristics, and then write the equation. Let's try to graph it first. Okay, so I have my 2 endpoints of the diameter graph. This is -6, -4, and -2, 2. I haven't labeled either of them as C because remember C, circle C, that means the center of the circle is at point C. Okay, and now I've drawn in that diameter, right? This is the diameter of the circle. That's what it says here. It asks us to graph the circle and find the characteristics of the circle, but one characteristic I can find right away. I know that the diameter of a circle passes through 2 points on the edge and also passes through the center of the circle. And it also says that the center of a circle is the midpoint of all diameters of the circle, which means if I want to find the center of a circle using the endpoints of the diameter, I'm going to use the midpoint formula. So I'm going to try to find the midpoint of these 2 points, the endpoints of the diameter. So first, I'll label the points as x1, y1, and x2, y2, and now I'll substitute them in. And now I can simplify. And now we found that the midpoint of the diameter, in other words, the center of the circle, is at -4, -1. We can actually label that as point C now, because we know that point C is the center of circle C. So let's plot that on the diagram. All right, so now we're halfway there. We know the center. Now all we need is the radius. If you recall, the radius of the circle is the distance from the center to the outside, and when we don't know that distance, we can use a little formula I like to call the distance formula. So let's use the distance formula to find the distance between these 2 points. Let's be specific. This point and this point, or really this point and this point. Doesn't really matter because what we're trying to do is we're just trying to find one of the radii. So let's pick 2 points to do that. First, we're going to write down the distance formula, which is the formula we're going to use here. Then let's pick 2 points. I'll pick this point, and I know I have to pick the center point, which is C. So it's this point here, and -2, 2, which is this point here. If I find the distance between those two, I'll have found my radius. My first step is to substitute the x2 and x1, and then the y2 and the y1 into my formula. Notice I'm not using this point because I'm not trying to find the length of the diameter. I'm trying to find the length of the radius, right? And now I'm going to simplify. So we have 2 squared and also 3 squared, and then we can simplify even further. And eventually we get a number that is an irrational number. R is equal to the square root of 13. That's okay. We're not going to turn it into a decimal because soon we're going to be asked to write its equation, and we can take this radical and do something very interesting to it. So now let's write out the equation of a circle, and of course you know the equation of a circle is this. Now we can substitute the values from the center and the value from the radius into this equation. And we know we can simplify this to positive 4, simplify this to positive 1, but the square root of 13, when you square it, that actually becomes much simpler because squaring and square rooting are opposite operations. So we're left with x plus 4 squared plus y plus 1 squared equals 13. So there's our answer, correct and complete. This is the equation of a circle, and it's a little bit more involved than the previous ones, but all we needed was 2 extra steps, one of which is to find the center and one of which is to find the radius, and you were able to do those with formulas that, frankly, you already know. Moving on past the check for understanding, which is not your responsibility yet, it's going to be your responsibility in class, so let's take a look at area and circumference. You know that the area and the circumference of a circle are the 2D space inside of the shape for the area, and the perimeter or the distance around the shape for the circumference. Both of these equations use the same variable. They use the radius r, 2 pi r and pi r squared. So if you know the radius, which is r, you can find the circumference of the area just by substituting it into both of these equations. So the check for understanding is going to be very straightforward. It gives you a circle, or actually 2 different circles, and it asks you to find the area and the circumference of these circles. I'll give you a preview of one of them. Let's give you the preview for circle E. The equation is not super necessary to look at except for the end of it, because I know that the equation of a circle is x minus h squared plus y minus k squared is equal to r squared. So since this is 9, this value is 9, I know the radius is equal to 3, which means I should be able to find the circumference by substituting that value into the formula 2 pi r, which turns out to be a very straightforward procedure. Yes, you can leave it as 6 pi. It's not asking you to find it to the nearest tenth or the nearest hundredth, so if it doesn't ask it around, just leave it in terms of pi. And you can do the same thing with area, but I'll let you figure that one out by yourself. All right, moving on to the summary, let's try to fill in these blanks, pause the video and see if you could try to do that, and then come back to see the correct answers. All right, the 2 important characteristics of a circle, as you know, are the center and the radius. You know that the diameter of a circle passes through the center of the circle, which happens to be the midpoint of the diameter, right? It's the point that's directly in between the 2 endpoints of the diameter. And then area and circumference can be found using the radius, which is part of the circle equation, because both of these equations have r in them. All right, this was the video on circle equations algebraically. Good luck studying.